it will be about cloud-based data privacy. And it's in the context of medical devices, but I assume it will apply to a lot of other environments, not only to the medical device points. So I will give you a very, very, very short overview about the data privacy laws, because I'm not addressing only GDPR. I'm addressing the Australian, the Russian, the Chinese, the Americans, and some other privacy laws, and how we, as an architects, can help our organizations or other organizations deal with the data privacy laws in the context. Then we will go through some of the technical controls and at the end some conclusions. First of all, a short overview. Over the world, we have various privacy laws or data protection laws. Many of them are portable, are aligned, are not contradictory. And that's good, because we need to implement it only one. Some of them are compatible, they are not contradictory, but for example, France has different security certifications than US. And obviously you need to know, you can still have a system which fulfills both of them, but you need to certify it twice. Others are contradictory, conflicting. We have this typical default for opt-in versus default being opt-out in terms of giving a consent to use the privacy data. Some countries have the data residency requirement where you are better not moving, you are discouraged, let's say, to move the data out of the country or of the region. And some regions or countries like the European Union encourage you to move. The three basic laws of the European Union is move of the money, goods, and people. And all of them are accompanied by moving data. Therefore, well, definitely data is movable in the European Union regulation, but obviously there needs to be fulfilled some requirements, some laws, some adequacy laws, and some solutions. A lot of these problems are handled by the legal and process controls at our company, Roche Diagnostics. There is probably around 1,000 or maybe more people working on the introduction of the GDPR. I will explain in the next slides why. But there are only very, very few people dealing with the technical controls. And this is when we, as architects, come to play. How we can help our colleagues from the data privacy officer not getting overworked or burned out. How we can save, well, depending on the size of the company, around, for example, for Roche would be around potentially $1 billion US dollar fine for a data privacy breach. David mentioned already the privacy regulations or the general data protection regulation in Europe, so I'm not going to repeat it, but there is one point which I want to make. It does not only apply to Europe. It applies to, for example, if you are a US tourist in Europe, your data is protected under European regulations. But if you are a company who, for example, like we, so far, I assume everybody knows, Switzerland is not in European Union. But nevertheless, we have a legal presence in the European Union. We offer goods and services to the EU residents, and we have employees in the European Union. For some of the companies, the third bullet may be also valid in terms of monitoring behaviors of the EU residents, for example, by them visiting the websites. Therefore, the GDPR, EU GDPR applies to many, many, many businesses. I'm not going to go through all of this, but there are some things which are very interesting for the GDPR and why I recommend to take a look at it, because it can be used as a benchmark in dealing with privacy regulations of other various regions. First of all, for example, it expands the special data categories to genetic data and biometric data. Additionally, it has the rights of individual very much extended. David mentioned the rights to erasure. This was his major point here, but we have also the automated decision-making, including profiling, which applies to whatever. Maybe applies to health insurance, maybe applies to voting in some countries. Data portability. You need to move to be able to enable the data subject, which can be patient, can be a person, move the data out of your system and transfer it to another system. So this is a regulatory requirement. But what's, I think, important for us is this was I marked red there. Data protection by design and data protection by default. This is where the architecture comes to place. This is where our systems from the beginning, this is not needs to be designed, developed, built with a thought about data protection. That's a very important aspect, I think, which enables us as an architect, giving us a lot of opportunity to deal with these things. Now, dealing with these things can be costly. So I will show you how our environment looks like, so where we just deal with it. So what we are medical device vendors. We are pharmaceutical, but here in this context, medical device vendors. So usually the healthcare enterprise, maybe hospital, has some laboratories with our equipment, medical devices, has some point of care equipment in the hospital. This equipment is usually connected to some IT systems in the hospital and through cloud or multiple clouds connected to our enterprise. And we are supplying data, we are consuming data, we are supplying services. Multiple clouds means in our case, we are very consciously not focusing on one vendor. We are using cloud of Amazon, Azure, Google, Salesforce, and some others. Additionally, we have some dedicated applications. Some of them are related to medical value. Some of them are related to data analytics. Some of them are related to device management. You know, when you have 100,000 or million devices connected, they still need to be managed. And in this picture, we have the patients which may be in the hospital, patients which may be in ambulatory care, or patients which may be self-managed. They are the yellow guys there. We have the operators of the systems. The operators have also their privacy, the operators of the hospitals. And we have the operators of our system and our service folks who also are identifiable persons. We need also to take care of their privacy. So that's the context. The, well, grayish rectangle is the big context of privacy that we are dealing, which means devices, our IT systems in the hospital, and clouds in between. Good. Now let's, it could cost a ton of money if we would be doing everything in a very, very complex way. So we just try to find the simple way. This is my role. I'm like the big old grandpa to the architects. So I try to find the simple, cheapest way for the business. Let's start with a common challenge. Actually, this is the same challenge mostly, but for different type of users, which was before in the LinkedIn presentation. Let's assume that a company, Acme or Roche, architected a system which is used in a laboratory, which is underlying the GDPR regulations and GXP regulations. The GXP is only in the context to tell you we need audit trail. So we are making audit trail. For years, we are required to save the audit trail. Now the operator leaves the laboratory XYZ. And same like in this scenario from David requires, well, remove my data. So how to do it in the cost-effective or cost-efficient way in the compliance with the GDPR? You have seen once, so I'm not trying to repeat the same, but there is much cheaper way in this context, and the regulations give us very explicit recommendation for doing it. The GDPR defines pseudonymization, which means if we have, and I'm not sure if I can use this mouse.
I think it points to the screen.
Oh, okay. That's complicated. Yeah, I'll do it. So, in general, the point is that we can use the reference, the pseudonym as a reference. For example, if our operator is John Smith, we use the pseudonym Smith1234, which is not identifiable personal data because it can be a lot of Smith1234. But this is a pointer or a reference to the user directory of the laboratory XYZ. And therefore, removing this user means for the laboratory XYZ, removing it from their user directory. We can keep still all this, well, hundreds of vendors of medical devices in a hospital, there are probably hundreds of them, can keep their audit trail records just by using the pseudonymization. This is something specific for GDPR. It's not recognized in regulations of all other countries, but if you are using it for Europe, you can use this one. And I guarantee you that it will be much cheaper than having this complicated searching in all of the records. It's not universally available. It cannot, for the situation with patients or for the situation with the LinkedIn users from the previous presentation, you still will need to have other solution. So this is, well, I'm architect also by trade. The first point was the decomposition of the technical controls. And this is our proposal or my proposal. So we will be talking not about all of them, but about some of them about data classification, data residency, encryption, anonymization, pseudonymization, key management, user access control, including the user residency, audit trail, data breach detection, and so on and so on. So I will not talk about all of them just because of the time constraints here, but about some of them. And in all of these talks, I will try to give you example of some principles and some recommended practices. And the practices sometimes refer to technology which we know or we try to use or we piloted. Does not mean that I'm promoting this technology only. There is a lot of technologies on the market, so just feel free to Google or find in another way different ones. So let's take a look at the anonymization because we started already with this one. So in general, you need to, the anonymization, pseudonymization, you should apply whenever you have data which is neither defined as public or you don't have a specific consent to use it in the specific context. And please remember, consent is used in a specific context. We will be talking a little bit later in the chapter or the slide on consent management. So, but in this case, when you don't have fulfill one of these, conditions, you must to either anonymize or pseudonymize or do something with the data. You cannot handle it differently, either you are illegal. So, anonymization, you can use, for example, this European reference, what techniques are recommended here. You can use the pseudonymization, as we have seen in the context before. The anonymization obviously preferred because it removes permanently the references from the data. It can be difficult because using some very specific exotic names and so on can be difficult. Pseudonymization is not a fail-safe because somewhere is the identity still stored. But here, the suggestion is don't do it in the same system which you are dealing. Do it in a different solution. Because if you do it in the same system, the pseudonym and the identity management doesn't save you money. Now, the pseudonymization is still preferred over managing the entire identity of the data subject. It's just much easier. In order to get to this, what data is public, what we need to manage, there is a point of having the data recognized as such, which means data classification. And these lists go, in our case, much longer because there can be various reasons. For example, this is for privacy. We identify confidentiality level, public, internal, confidential, or secret. But don't forget, the confidentiality is driven, for example, by intellectual property laws or by trademark secrets, trade secrets. Therefore, it's not only one reason. You can use these labels or some others. The point is, get them somehow aligned with your organization or with the entire industry if possible. There is no universal standard for this so far I know. Why the alignment? It will be much easier to design the policy to deal with the data. And obviously, later maybe use data analytics or another discovery. There are some simple principles. When you have various label classes, obviously the strictest label apply like in this confidentiality level of the location contained. Now, how you find this data, how you classify it, and if we are talking about clouds here. So all of the majors, and there is a lot of other on the market, supply you with some services, classification services. So for example, AWS has Macy service, Google has excellent data protection API, data loss prevention API, and Azure has the DG Secure. So use it. You will be much better than trying to identify the data, let's say by human beings. These services are based on, usually on machine learning, and they are pretty good. So far, we played with them. Everybody took a picture? Okay, and there's next one. Data residence. As you see, here is no GDPR reference. I usually try to put some reference for the GDPR. Here is not, because the GDPR is promoting, as I mentioned, the data transfers, but some countries don't. Russia, for example, has regulations which, well, would demand that the data, or at minimum the master version of the data, stays in their country. And therefore, when we are designing a system, we should keep this in mind and do whatever is possible to keep this data in the region. Because if we are, like for Roche, designing systems which goes into around 110 countries, well, better try to find a common solution for this and not do individuals. So first of all, try to keep it in the region, but definitely not move it out of the region unencrypted. It must, if you are moving out of the region, it needs to be encrypted. But this is a nice feature. Consider the data residency we can change to a key residency, which means the data can be located in whatever data center worldwide. We can move it, which enables us to utilize the technology of the cloud in terms of scalability, availability, and so much better, but we keep the key management locally in the region. One of the next slides, I think, about the key management in more details, but in general, this may be not permitted in every of these regions. So still, in this case, well, there is a lot of possibilities. You can get through, designing the VPCs, identity, virtual private clouds, identity management, network control list, access control list, security groups, key certificates management, whatever use the mechanisms which the cloud providers are giving us in our hands as tools to contain the data within the region. It's possible. And, well, in some cases, when you have really very paranoid customer, for example, whatever, Department of Defense, not necessarily US. US is, by the way, on Azure and AWS. So, but anyway, if you have it, you can use the local deployment of a cloud, which, for example, if you are developing on Microsoft Azure, you have the nice feature that you can use the Azure Stack. It has some limitations, but usually they are not so significant, and you can still keep your one development tools, stream, whatever, and you can say, okay, dear customer, you don't want to be on the public cloud, just we install in your data center the Azure Stack. You will have limitations by the nature of it. You will not have this type of availability, redundancy, and so on, but you can run it locally. So cloud vendors are delivering us a lot of opportunities to deal with the privacy, and this is one of them. Key management. Who is responsible for the keys management? Not the cloud service provider. Maybe not you as a company which is running this on the cloud. Definitely, this is the role of the data controller. I mean, this is the GDPR differentiates between data controller, data processor, data subjects. And by the way, what David used, PII, personal identifiable information, in GDPR is personal data. So the wording is different. But in general, data controller is this organization who is responsible for your data because you, as a user, gave the consent to deal with your data. Now, therefore, whatever you do in the key management, whoever is a data controller, they need to have access to the keys and manage the keys. We talk about the key storage, but what's important is that you should be able to withdraw the key from, well, whoever may be losing the consent or this role, or definitely the cloud service provider should not have effective control over the key. That's important. So no Amazon, no Azure, no whatever, Google should have the control over the keys. The keys should be valid only for a limited amount of time. They should expire automatically, and whatever you do it, you can do like, for example, Amazon, the keys for IoT are expiring within 7 days. Maximum, we can prolong it to 30 days. This expiry date. To the last point about information right management, I will come when I just display you some of the recommended practices. But generally, a lot of the cloud service providers, or let's say all that I know, have reasonable or very good key management capabilities, which means there is a fully managed service. You can use this one to generate, store, enable, disable, delete, and what keys. They can say, okay, they will manage it for us, or we can manage the keys, or the data controller can manage the keys using hardware security modules or software security modules. They can regionalize this key storage. Very, very good service in keys of management, can strongly recommend. And the last point, the information right management. It would be nice if everything would be encrypted and a document or whatever file which you try to access the file would know whom to call and ask if, for example, if Harald wants to access my file, so the file should know where to call and ask if Harald has access to this file. So therefore, the information right management here are, I don't go into the entire theory, you can find of it, but in general, we have data which is encrypted with the key. The key is protected by the policy, also stored with or let's say accompanying the file storage, and the blue key there is this actually the information which enables who has access to the key. We will have also some view on this in the user managed access in the slides about consent management. So I recommend this technique. We will be piloting it probably this year, depending a little bit on with one of the cloud service providers, and also in the context of user managed access. And there we are in the consent management. Important is that the consent management is very fast. If Harald is my doctor and I am lying, after accident, he needs to have access to this one, and however he gets this content needs to be, instantaneous. So therefore, no delays, no complex processes, and the best obviously is if the user managed access. If, for example, I can give the consent to this person and not an institution or organization or operation team needs to do it on my behalf. So therefore, we need to differentiate between the metadata of the consent itself and the data subject attributes. I strongly recommend the self-service consent management, and obviously, well, least privileged, this is maybe not so obvious, but it is also strongly recommended. Get this consent so that after certain expiry time, it will be just withdrawn automatically. This supports the GDPR requirement also on this consent management, on the having the access to the data. And obviously all transactions shall be audited. So there are some, well, not public standards, not maybe so existing many APIs, but there is one which is getting more and more, I think, popularity, is the user managed access, UMA. You have links there, and it is a little bit similar to open out as a protocol, but deals differently with the servers and deals with the, with the authorization server and resource server and some tokens which is passing, and I'm not going to, you can read in the Wikipedia or wherever there is enough information about user managed access, but it's an API which is probably currently, let's say, one of the better on the market in terms of enabling the consent management for various applications. I cannot claim that it has market penetration or whatever percent, but we intend to use it, and I know some other healthcare organization try to use it. It even has the health relationship trust profile, which is a profile of the UMA. And you could combine it with the information right management. This would be really nice. So if there is a startup here who wants to work on this, just say hello. Good. Now we are nearing to the data subject specific functionality. This is maybe to some extent specific for the GDPR, which is related to, first of all, every patient, every person needs or have the right to know what happens to their data. If the data gets transferred from LinkedIn to Facebook or whatever, this person should be able to access that this transfer happened. Same if hospital A sends some information, medical record to physician B for consultation, this information needs to be accessible. So this first point. Second is we should be able to correct our personal data. And correct it means, for example, there was years ago, the previous president of Germany, his wife was accused on the internet that she was a hooker at some point in her life. Well, it was false accusation, but what happened, obviously, every search for this lady name resulted with the thousands of hits while she was a hooker. Well, you need to be able to remove this type of data from the internet, which means delete data from internet. That's its nice requirement here. There are obviously some constraints. You cannot remove some data which is related to crime and so on, but in general, there is the requirements that we should be able to remove our data or correct the data. Now, how to do it? If you have sophisticated audit trail logs, and this will be one of the next slides, then you can just do it from the audit trail. Obviously, it requires that the sophistication of audit trail means that what events are you capturing there and what data with the event you are capturing. And obviously, in terms of the erasure of personal data, depending on the granularity, let's assume that I have, the granularity needs to be very, very fine if possible. If I break my leg, well, I don't care if Roche, my employee, knows it. Everybody sees it anyway. But if I would have mental health or another, not nice health problems, I maybe would care that my insurer or my employer don't know it. How you can solve it? If we have the granularity on this type of information bound to every record, we can just use it for the consent management, to give the keys only to people who need to know, and also for the erasure of personal data. Removing the key, destroying the key means erasure of the data. Practically scrambled, you cannot access it. Audit trail, and we will come to the encryption and also the longevity of encryption in one of the next slides, but to audit trail. Well, there is a lot of audit trail, and I'm not going to, everybody is doing audit trail, so all this information, what protocols, and there are some specific, more or less, formats for medical type of audit trails, and so on and so on. So obviously it needs to be encrypted, immutable, and so on. What's probably here more important is what events are we capturing, and here is a short excerpt from events of our systems. I'm just trying to look at the personal data events, and I know they are very small there, but there are something like creation or submission of personal data record, modification, update of personal data record, deletion of personal data record, query or access to the personal data record, transfer of personal data record to some other system or other location. And so creation of a consent data record, modification of a consent, revocation of a consent. All of these events are really related to the protection of data in terms of privacy. And you can obviously have more data. This fourth part here, system operation events are related to the medical devices or medical IT systems, and the upper are like, I think everybody has the registration or request of a new user. Encryption shortly. The encryption should be for data in motion and data at rest, but it's the same for like all of them, so here's nothing new. The point is that in case of medical devices, we need to authenticate the sources and destinations, because obviously also in terms of privacy, if we want to identify where the data moved, we need to know where it moved from. So that this was authenticated device or a system and moved it to another authenticated device to a system and to somewhere else. So this is you can use here the mechanisms which are provided by the actual cloud service provider or IT service provider, or just use certificates or whatever other keys you can use here. The metadata should be, if possible, clear text. What I mean by metadata? Yeah, for example, if you are using archival for medical device of the data which participated in making a medical diagnosis, then we leave the device identification, chemistry reagent identification, and the consumables specification in a clear text. Why? Because we want to be able to, within the next 20 years, to look for if somebody died, for example, because of whatever cause, but there is certain suspicion that it may be because the diagnosis was wrong, we need to search for it. But we should not search in a clear text for the patient. We should search in a clear text for the context in which the patient was diagnosed. So here is a challenge here. Encryption, well, depending how important it's for you, for us to some extent is important as a company using the format preserving encryption. For details, look at the NIST. I'm not going in the details of the techniques and technology here. The current minimum crypto strength for us is what's written here, but it can change. It is changing from year to year because the computing power of it for decrypting it by brute force or whatever is increasing. Therefore, the last point here, please consider that if you are storing data long term and for some regulatory purposes for accreditation of laboratories it is required to store it for up to 20 years, it will require re-encryption, which you can do it by decrypting and re-encrypt it with longer key or another algorithm or whatever, or you maybe just additional envelopes like putting like this one safe in another safe in a bigger safe and so on. Type of like the matroshkas of the Russian dolls. Last point, and I'm just done coming to conclusion, and it's just point of the data breach detection. Well, you need to detect the breach, and you must inform the data subjects, either directly or, depending on your role, or the data controller, who then informs this data subject. But which means that you need to collect a lot of data just to be able to know where the data breach occurred and whom to inform. So this is also part of your audit trails when the records are moving, for example. And this needs to be proactive. There is, in the meantime, a lot of tools on the market which can analyze behavior, communication behavior, user behavior, and so on. So you can deal with this. Some of them are running on cloud, like cloud access security brokers, or some anomalous behaviors by third party, or Eastwind, I think, is one of the companies who also supplies this type of behavior analytical monitoring. The important point is that the notification process should be started within 72 hours. It's much shorter than, for example, HIPAA requirements in US. So in many countries, you need to target that you will be really informing automatically. Obviously, if you have the detection, why not to stop it automatically? So consider this, not only the detection, even if the detection is required, but consider also stopping. Good. Final conclusions, and we can go for lunch or questions. First of all, I think that despite the differences all over the world between the various privacy, data protection laws, and so on, we can find some common architecture solutions for whatever our technical controls will be. Well, I started with this just because the GDPR is a big buzzword, and let's say as architects there was some needs for help, let's say, and getting someone to sit on this. So I'm not claiming that the GDPR is the best and most appropriate regulation, but it's a good starting point. It's a comprehensive, it has some good recommendation, and what I know also from our legal people is if you are fulfilling GDPR, you have a pretty good probability that you are fulfilling many other privacy regulations. And there is obviously the data residency aspect, which is a very different one, but this is the only one which can be really contradictory. The popularity of cloud is growing. In the healthcare cloud, the HIMSS analytics data is that like year-to-year growth is 62%. In the healthcare, it started like 4 or 5 years maybe ago, so it's really amazing growth. And the cloud providers are supplying us with a lot of tools, and the tools we can use them, the data classification tools, the Azure RMS, which is the information right management on Microsoft Azure, for example. Consider using these tools which they are supplying in design. I know that we are potentially binding ourselves to some of the platform. I'm not negating this, but these tools are so good that in the meantime, I would definitely rather be there than paying the fine. I didn't mention, but for the GDPR is 4% of up to 4% of annual global turnover of a company, which for Roche it may be $1 billion US. So it's big. The fines can be big, and if you imagine European country which may have some difficulties financial, like Greece, well, what's the best point of getting their finance improved? So therefore, use these tools. They can help us to lower maybe not to 0, but from 4% to 4 promille, and then will be much cheaper. And through my work with with the cloud vendors, I can tell you they are usually very responsive. In particular to the privacy challenges, we can demand from them something, and we have a pretty good chance that they will implement it within the next whatever month or year, or will buy a startup which will help solving this. That's all, folks. Thank you.
I should. Yes, good job. Okay. So the only thing between us and lunch are questions. Hello? Yeah, the only thing between us and lunch are the questions. So I'm not saying that you shouldn't ask questions, but I'm saying that keep it brief. Are there any questions, by the way? Okay, I have one question. Yes. And I was, just to show I was paying attention as well. You said in one of your slides that when you were encrypting data in motion, you were encrypting the personal identifier data, but you were not encrypting the metadata. How worried are you about data leaks from traffic analysis on the metadata?
Well, this is maybe specific for our transfer, but our metadata are the device identifier, institution identifier, where the device is, the consumables or reagents identifier, so not really related to the people. And we need it actually for traffic, for directing of the traffic to the appropriate data centers. For example, also in terms of the data residency. So therefore, we are not concerned too much about it.
Yeah. Thank you. Any other? Yes, we have another question.
It's the same question. So you said you are sharing the device data, but that could be inferred, right, to that nature would lead into the personal data.
Okay, that's a good question, but it's probably my fault that I was not specific enough what device I meant. So obviously, if you have this consumer type of device which is associated with a person, yes, this would be associated with a person. But what I meant by the devices here in this case are the laboratory devices. Some of them have capability making 20,000 results per hour. So there is a lot of throughput and a lot of dealing with patients. So like thousands of patients' data passing through the system. Therefore, we just are not so concerned for the laboratory device. But you are fully right, correct, with the consumer type of devices.
Thank you.
And it just goes to show that you have to pay attention to the metadata so that you don't inadvertently leak something. Yes, another question.
In terms of the regulations, how does when it comes to like where the data is stored and where it's allowed to be transported through, how does the user's location matter? So, for example, they're a Russian user and they store their data in Russia, but either they or someone elsewhere accesses their data, say, from their web browser. How does that play in?
Well, unfortunately, it really matters from some countries, and it's you look at UK, the National Health Service of UK also demand that the users accessing the patient data will be located in UK. And it's a very, very difficult problem because, you can spoof anything from, from IP to URL to using VPNs to, So therefore, if you are in a country like which isolates its user from rest of the world, then for this country it's kind of like more or less easy. You cannot get through the big firewall, for example, from the outside. Otherwise, we just didn't find yet a method to uniquely identify the user besides of having authorized users equipped with, our credentials. Credentials can be certificates, can be RFID keys, whatever, but they are with the credentials, and we check the credentials. But we cannot say if the user is not moving around outside of the institution. We have some provisions that, for example, when the data is on a mobile device and the mobile device gets out of the geoperimeter of a laboratory, the data will be wiped out from this device. But this is for a different scenario. This is for avoiding that, for example, when the doctor goes with the device with the patient record home and the kids sees that there is maybe whatever celebrity data and shares it with their friends. So that's the point of wiping the database on geolocation. But universally, we don't have solution for this problem.
Okay, then I guess it's lunchtime. Thank you all.